In this video we will dive deep into the fascinating world of JSON. Whether you're a beginner or have some experience, this video is designed to help you understand JSON from the ground up. Let's start. What is JSON? JSON stands for JavaScript Object Notation. It's a lightweight format for storing and transporting data. It's easy for humans to read and write, and easy for machines to parse and generate. Think of it like a book. Each page in the book contains specific information. JSON does the same, but digitally. Consider this simple JSON. It looks very much like a dictionary, right? Each pair consists of a key and a value. Why JSON? JSON has become the de facto standard for data interchange on the web for a variety of reasons. Let's delve deeper into the reasons why JSON has gained such widespread acceptance. Human readable. JSON is a textual format that is easy to read and write. Its simplicity means that it is easily understandable both by humans and computers. This aids in debugging and also makes it straightforward to manually create or modify data. Lightweight. Compared to other data representation formats like XML, JSON has a more compact style. This compactness leads to faster data transfers, especially useful in web applications where speed and latency matter. Language agnostic. JSON parsers and generators are available in almost all programming languages. This universality ensures that applications written in different languages can easily share data. Structure and flexibility. JSON can represent complex hierarchical data structures, offering a mix of nested objects and arrays. This provides flexibility to represent diverse data forms. Widespread adoption. APIs, especially RESTful services, have widely adopted JSON due to its ease of use and universality. As a result, tooling and community support around JSON are extensive. No need for a schema. Unlike some other data formats, JSON does not require a predefined schema to structure data. This allows for dynamic and flexible data structures. Easily parsable. JSON structure makes it very straightforward to parse and convert into other data structures, like objects and object-oriented programming languages. Efficient serialization and deserialization. Converting complex data structures into JSON, serialization, and converting them back, deserialization, is efficient and less cumbersome than with other formats. Statelessness and data interchange. For web applications following the REST principles, JSON provides a stateless, easy to parse, and easy to generate data interchange format. Native JavaScript format. Given that JSON stands for JavaScript Object Notation, it's native to JavaScript. This made it extremely popular for web applications, especially with the rise of AJAX and single-page applications. Support for mobile and web apps. Given its lightweight nature, JSON has become the preferred format for mobile applications that rely on quick and efficient data exchanges. While JSON offers numerous advantages, it's essential to remember that the right data interchange format often depends on the specific needs and context of an application. There might be scenarios where other formats, like XML or protocol buffers, might be more suitable. However, for a vast array of applications, especially those on the web, JSON remains a compelling choice due to the reasons mentioned here. Now is the question, where JSON is commonly used. APIs and web services. Preferred data format for exchanging information between servers and clients. Configuration files. Used for storing software and application settings due to its readability. Data storage. NoSQL databases like MongoDB use a JSON-like format for storing data. Data interchange in web apps. Facilitates asynchronous data fetch and submission in web applications. Mobile application development. Efficient data format for mobile apps communicating with servers. Configuration management and deployment. Tools in DevOps use JSON for deployment and orchestration tasks. Browser extensions. Commonly used format for browser extension configurations. Serialization and deserialization. Provides a format for storing or transmitting data for later reconstruction. Game development. Modern game engines use JSON for data storage and configuration. Geospatial data interchange. GeoJSON encodes geographical data in a JSON format. Online advertising and marketing. Used for transporting ad content and user metrics data. Real-time applications. WebSockets and similar technologies transmit data as JSON for real-time interactions. In essence, any scenario requiring a lightweight, easy to parse, and widely understood data interchange format can benefit from JSON. Its ubiquity and ease of use have led to its adoption across diverse domains and technologies. Let's now dive into the structure and syntax of JSON. There are three main points you have to understand, so that you can write a JSON object. These are the following. Basic structure of JSON. Basic syntax rules. Data types. Let's start with the first one, the basic structure. JSON is built on two basic structures. A collection of key-value pairs. In various languages, this is realized as an object, record, dictionary, hash table, keyed list, or associative array. An ordered list of values. In most languages, this is realized as an array, vector, list, or sequence. In other words, JSON consists only of two parts, objects and arrays. Let's move on to the syntax rules. There are different rules you have to follow in case you want to create a JSON object. Data is represented in key-value pairs. Curly braces hold objects, key-value pairs. Square braces hold arrays, lists of values. Keys are strings, written in double quotes. Values can be strings, numbers, objects, arrays, Boolean or null. These are the data types we can use to write JSON. Each key-value pair is separated by a comma. Let's check the different data types, how to use in JSON. String. Enclosed between double quotes. For example, hello world. Number. Can be integer or floating point. For example, 123 or 23.45. Object. Collection of key-value pairs enclosed in curly braces. For example, the following object. Array. Ordered list of values enclosed in square braces. For example, this array of strings. Boolean. Represents true or false. Null. Represents an empty value or nothing. Let's consider some examples of writing a JSON object using this information. Suppose I want to store the data of a person in JSON object, such as the name and the age. Let's write this data as JSON object. First I have to add curly braces to write the different key-value pairs. Let's start with the first key, name. As mentioned, keys are strings and should be written in double quotes. Now the value of this key. It's a string, therefore I wrote it in double quotes. The first key-value pair is ready. Now I want to add another key-value pair, therefore I have to add a comma. Now the second key in double quotes like the first key. Then the value, which is a number, therefore I will write the number directly without double quotes. The second key-value pair is also done. In this way I have the data I want to store in this JSON. Suppose I want to add other key-value pairs, for example the following. I can do exact the same as I did for the first two pairs. Student is of type Boolean, therefore I added the value true without double quotes. The next key is of type array, therefore I added the values inside square braces. As you can see, I also added a comma after each key-value pair, but not after the last one, else the JSON object will be invalid. So, trailing commas are not allowed in standard JSON. For example, this object would be considered invalid. The second thing you have to note, that keys are case sensitive. So, name and name would be treated as two different keys. One last thing I want to mention, that JSON doesn't support comments. So, you cannot add style comments in a standard JSON. Let's check another example of a JSON object, which is called as nested JSON object, because we have object inside object. I have different key-value pairs. The following key-value pair is of type object and contains key-value pairs. These pairs follow the same rules and are written in the same way. In this example we only have an object inside object, but we could have many different objects inside the objects. In this way we can store more data about each single key in case we need that. These examples should give you a clear idea of how to structure JSON data. The array I used in the examples was to store strings, but you can also store other data types, for example objects. This is how to write a JSON object manually. Let's now check how to do that using a code. Adding data to a JSON structure or creating a JSON from scratch in VB.NET is typically done using the Newtonsoft.Json Library, also known as JSON.NET. This is one of the most popular libraries for working with JSON in .NET. So, we first have to understand what does this library contain and how to use, before start using it. JSON.NET provides a host of features to work with JSON, such as converting .NET objects to JSON and vice versa, serialization and deserialization. Serialization is the transforming of a data object into a JSON string that can be saved to a file or sent over the internet. Deserialization is the opposite process. It's to convert a JSON string back into a data object. Querying and manipulating JSON objects. Supporting LINQ to JSON, which means that you can use LINQ to query and manipulate JSON data structures provided by JSON.NET. These are some features of this library. JSON.NET contains different namespaces. I will talk about 2 namespaces in this video, which contain the most important classes and methods we need. These are Newtonsoft.Json. This is the core namespace and contains the principal classes and methods for serializing and deserializing objects to and from JSON format. Newtonsoft.Json.Linq. This namespace offers classes to work with JSON as LINQ-compatible objects. Let's check some of the most important classes and methods under both namespaces. I will start with this namespace. The first 2 classes are JObject and JArray, which are to represent the main 2 parts of JSON, objects and arrays. Each class provide methods for manipulating JSON objects or arrays. Let's check which methods do we have inside each class. Parse method parses a JSON string and returns a JObject. 𝗖𝗵𝗄𝗽𝗀 method converts the JObject to a .NET object of type T. Add method adds a property to the JObject. On the other side we have the following methods. Parse method parses a JSON string and returns a JArray. 𝗖𝗵𝗽𝗀 of list of T converts the JArray to a .NET list of type T. For example, to convert an array of string to a list of string. Other available classes are JValue and JToken. JValue represents a primitive JSON value, for example a string, number, boolean, etc. JToken is the abstract base class for all JSON values in JSON.NET, like JObject, JArray, JValue. We have many other classes and methods inside this namespace, but I will not mention each one in this video. If you want to learn more about this namespace, please check the following link. Here you can find the documentation of all classes and methods of this namespace. That's all about the first namespace. Let's check the second namespace, Newtonsoft.Json. I will explain only one class, JsonConvert. This is the main class you'll use for most serialization and deserialization tasks. Some methods of this class are the following. SerializeObject converts an object to its JSON representation. DeserializeObject of T converts a JSON string to an object of type T. SerializeXML node converts an XML node to its JSON representation. DeserializeXML node converts a JSON string to an XML document. There are many other methods under this class, and also other classes under this namespace. To learn more about these classes and methods, please check the following link. You will find everything you need about this namespace. This was a briefly introduction for both namespaces under the Newtonsoft.Json library. Let's now learn how to use this library to create or edit a JSON object. First thing we have to do is to import both namespaces, so that we can use their classes and methods. In code we can do that using these 2 statements. In UiPath we can do that under Imports tab. The second important thing you have to learn is the parse and load methods. Both methods are used to create JSON objects or arrays from different sources, but they accept different types of inputs and are found on different classes. Let's check the differences between both methods. I will start with parse method. It's used on JObject and JArray classes, to convert a JSON string to a JObject or JArray. It's typically used when you have the entire JSON data available as a string. We can use this method in these 2 ways. The first one is to convert a JSON string into a JObject. The second one is to convert a JSON string into a JArray. For example, the following code. First I am reading the JSON file and storing it as string in the variable JsonContent. This is in case I want to read the file using a VB.NET code. But if you want to do that using UiPath activities, you can use the activity, read text file. After that I use the parse method to convert the content to JObject. If I want to convert it to JArray, I can use the following statement. In this way I converted the string to JObject or JArray. The type I have to use depends on the JSON content I have. If the content of the file represents an object, you have to use JObject. But if the content of the file represents an array, you'd use JArray instead. This is how to use parse method. Let's move on to the next method, load. It's used on JObject and JArray classes, but also on other JToken-derived types, to load JSON data from a JSON reader instance. It's handy when reading JSON data progressively from streams. Load method can be used in this way. First I defined a stream reader and used it to read the file content. After that I use load method to get the content as JObject. I can do the same to get the content as JArray, in case the file content represents an array. This is how to use load method. In summary, parse method is used once we have the JSON as string, and load method is used once we have the JSON inside a file. That's all about both methods, which we will use later in the examples. Let's start with the first example. I have the following JSON file, which represents an object. I have here different properties, such as student ID, name, age, is student, address, etc. Address property is of type object and contains key value pairs. Subjects property is of type array and contains strings. Grades property is also of type object. The whole JSON file represents an object, because the text is added inside curly braces. So, I want to read this file and convert it to JObject. After that I want to print out some of these properties. Let's start implementing this use case. First I have to read the JSON file. This can be done using the activity read text file. Here I added the file path. You can also use a variable for that, which contains the file path. Now I will create a variable to store the output of this activity. It's of type string and contains the JSON file as string. So, we have the JSON as string now, therefore we have to use the method parse. If you want to get the content directly from the file without reading it, you can use load method. Let's continue using parse method. First I will create a variable of type JObject, because the file content is an object. This is not a standard type, therefore I have to browse for this type as follows. As you see, I found the type under this namespace what I explained before. Now I will use the parse method to convert the JSON string to JObject. Here I use the variable JsonContent, what I got from the activity read text file. Now the variable JsonObject contains the JSON object. I can use this variable to read the content of the JSON. Let's print out some properties from the JSON object using write-line activities. I can do that in this way. I am using the JSON object variable with the property name. I will print out 3 different properties. I used only the simple properties, not the objects or the arrays. Let's execute the code to check the output. As you can see, I got these 3 values as output, which are the name, age and is student properties. This is how to read simple properties from a JSON object. Let's now see how to return the array property in UiPath. Subjects property is an array of string. First thing I have to do is to create a variable of type JArray. I will browse for this type as I did for JObject. It's also under the same namespace. As you know, I converted the JSON string to JsonObject before. It's now stored in the variable JsonObject. Now I want to use this variable to get the subjects array. And I will use the parse method to convert this property to JArray. Now the variable JSON array contains the subjects array. Let's print out the values of this array in the console. I will use string.join function to print all values of the array in only one line with a separator. Let's execute the code again to check what happens. Here I have the old 3 outputs from the previous steps. In this line I got the content of the array subjects. I got these 3 subjects, which I have in the JSON file. This is how to get an array property from a JSON object. Let's now try to get the data from the object address, which is an object property inside the JSON object. This will be exact the same, as I did for the whole JSON object file. I have to use JObject type to parse only this property, so that I can read the different properties later. I will copy this assign activity. I only have to change the string I want to parse. In this case, I should use the property address. Now the variable JsonObject represents only the property address. Using this variable, I can read the street, city, and zip properties, which are available under address property. So, I will add a write-line activity to print each property. These are to print out the street, the city, and the zip code. Let's execute the code again and check the new result. As you can see, I have below 3 new outputs. These are the street, the city, and the zip code. This is also how to get an object from the main object. I can do the same in another way. To get, for example, the address object as JObject, I can use the following statement. It returns exact the same result as the first one. So, you can do both to read an object from another object. The example I showed you was about a JSON object, where the whole text is written inside curly braces. Let's now check another example, where the text is written inside square braces. So, the JSON text here is an array, and it contains 3 different items. Each item has 2 properties, name and age. Let's see how to get the values from this file. I already added the activities. First, I added read text file to read the JSON file. The output will be stored in the variable JsonContent. After that, I used an assign activity to convert the JSON string to JArray. Here I used the parse method to convert the string to JArray. At the end, I added for each loop to print out the content of the JSON. For each item, I am printing out the name and age, which are the only properties I have inside the JSON. Let's execute the code to check which output I will get. As you see, I got the names and ages from the JSON file. I got 3 names and 3 ages. These are the properties of the 3 items I have inside the JSON array. This is how to parse JSON string and read the different values from JSON. I used only parse method, but you can also use load method. Let's check the following example of using load method to do the same, what I did in this example. So, I want to print out the content of this file. I added only one activity, invoke code. Here I use the following code. As you see, we don't read the file as string, but we directly read the file and convert it to JArray type. After that, I added this loop to print out the name and age of each item. Let's execute this code to check the output of this code. As you can see, I got the same result, what I got before using parse method. I have 3 names and 3 ages. This is also how to use load method with JArray type. The same will be for JObject type. These are the basics you have to learn about JObject and JArray. In case you want to learn more about all classes and methods of the Newtonsoft.Json library, please check the links I showed you. I used in the example only the classes JObject and JArray, but we can also use the class JsonConvert to achieve the same. For example, I use this assign activity to convert the JSON string to JObject. I can use this assign activity to do exact the same. The same is also for the JSON array. I use this assign activity to convert the JSON string to JArray. The same can be achieved using this activity. In summary, DeserializeObject method is like parse method, to convert a JSON string to JObject or JArray. These are the different ways you can use to convert your JSON string to JObject or JArray, so that you can get the data you need from JSON. Let's now move to another part of this video, where I will show you how to create a JSON object in UiPath. First, I will create a variable of type JObject, where I want to store the created JSON. As default, I will write the following statement. It's very important to use, else you cannot use this variable later. This statement is to declare the variable I created, so that I can add properties with their values later. Now I will start adding the properties to the object. The first one I want to add is the name. I can do that in this way. On the left side, I added the property. On the right side, I added the value of this property. It's like adding key value pairs into a dictionary. I will add another property, age, for example of type number. Let's add another one of type Boolean. This is how to add the types, string, number, and Boolean. Let's now see how to add an array to this JSON object. On the left side, I will add the property name as I did before. On the right side, I will first define a new JArray. Inside the braces, I will add the values I want. For example, these three values of type string. This is how to add an array to JsonObject. Let's now see how to add an object to this JSON object. For example, the object address, which contains three properties, street, city and zip. First, I will create another variable of type JObject and set the default value, as I did for the first variable. I will use this JObject variable to add the properties and values I need. Later, I will add this variable to the main JObject variable, which contains all other properties and values. Let's add the properties one by one as I did before. The first activity is to add the property street of type string. The second activity is to add the property city of type string. The third activity is to add the property zip of type string. Now I have these three properties inside the new JObject. Let's now add this new object to the main object. I can do that in the same way like adding any other properties. On the left side I will add the property name, address. On the right side I will add the object, which is now stored in this variable. In this way I added an object to the JSON object. Now I will create a new variable of type string, to store the JSON object as string. I want to convert the JSON object to string and store the output in this variable. To convert the object to string I will use the following statement. Here I use the method serialize from class JsonConvert. This method is to convert a JSON object to string. At the end I will add write text file activity, to write the JSON string in a JSON file, so that we can see the output of this code. Here I will use the JSON string variable, which contains the JSON object as string. Here I will add the file path, where I want to write the string. The sequence is ready now. Let's check the activities I added to the sequence. The first three activities are to add three properties of type string, number and boolean. The next one is to add a string array. The next three activities are to add three properties to the address object. In this activity I added the address object to the main JSON object. This assign activity is to convert the JSON object to string type. And the last activity is to write the string in a text file. Let's execute the code. The execution is finished. Let's check the new created JSON file. I will format the JSON string to make it easy to read. This is the JSON object, what I created using the UiPath sequence. Here you can see each property with its value. This is the string array. And here is the address object, which contains these three properties. This is how to create a JSON object using UiPath activities. You can also use these activities to create a JSON array that contains different objects. You can also do the same using invoke code activity, without using assign activities. That's all about JSON for now. Before we wrap up, a quick reminder. Make sure to check out the links I provided in the video. They contain valuable resources and examples that will reinforce what we've covered today. And remember, like with any skill, practice is key. The more you engage with JSON and apply what you've learned, the more proficient you'll become. So dive in, experiment, and keep practicing.